Okay, so the first gas law we're going to talk about is Boyle's law. Now, Boyle's law states it states that the volume of a gas varies inversely with its pressure at a constant temperature. Okay, so when we're looking at our gas law questions, the things that are going to be manipulated are going to be pressure, volume, and temperature. So they all have some sort of effect on a gas. So your formula for this case is going to be P1V1 is equal to P2V2. So the word inversely proportional means that if one goes up, the other goes down, or vice versa. Okay, so we're going to look at 3 example problems, and you should be good to go for your worksheet. So our first example problem. A sample of oxygen gas occupies a volume of 250 milliliters at 740 torrs of pressure. What volume will it occupy at 800 torrs of pressure? Now, it doesn't matter the units that we're in as long as they match on both sides of the equation. So we're going to write our equation. P1V1 is equal to P2V2. Your first pressure is going to be 740 torrs. Your volume is 250. Now, our second pressure is going to be 800 torr. So we just put 800 right here. We're going to solve for V2. So we're going to multiply these two numbers together. We're going to divide by this side, simple algebra equation. And you should get V2 comes out to be 231.25, and we're going to be in milliliters, the same unit as it was on the previous side. Okay? And let's look at another example. Hopefully I can fit it on this page. Get all my stuff away. Okay, so a sample of carbon dioxide gas occupies a volume of 3.5 liters at 125 kPa pressure. What pressure would the gas exert if the volume was decreased to 2 liters. Now, from Boyle's law, we can predict that if the pressure goes up, the volume should go down. They're inverse relationships. So in this case, our volume is going down, so our pressure should go up. So we're going to use our formula. P1V1 is equal to P2V2. Your P1 is 125. Your V1 is 3.5 liters. We're looking for P2, and our V2 is going to be 2. We're going to do it just like we did in the previous equation. We're going to multiply these two numbers together and divide by that one. You should get 218.75, and we're in kPa because our original pressure was given in kilopascals. Okay. Now, let's do a little bit different question where we have to do some sort of conversions in it. Okay, give me just a sec. Okay, so let's do fluorine gas exerts a pressure of 900 torr. When the pressure is changed to 1.5 atmospheres, its volume is 250 milliliters. What was the original volume? Now, as we go through this question, we notice that the pressure units change from torr to ATM. Now, it does not matter which units you get it in. You can get torrs to ATMs or ATMs to torrs. It does not matter. So I'm going to convert the 8 ATMs. Okay, so we go 1.5 ATMs, just like we did in the last lesson. Now we know that 1 atmosphere has 760 torr. So we're going to multiply 1.5 times 760, and I get 1140 torr. So that's going to be my P2. Now we're going to use the same formula we used before. P1V1 is equal to P2V2. Your P1 is going to be 900. We're looking for the initial volume. P2 is going to be 1140. And its volume was 250 when it was changed. Okay, so we're going to multiply these two numbers together, divide by the 900, and we get our answer. And you should get 316.67, and we're in milliliters. Yeah, milliliters. Okay. So I will be sending out a worksheet that goes with Boyle's law, and that will be due towards the end of the week. Just trying to divide it into short chunks. If I get a chance, I'll put Charles' law up there so you can work ahead. Have a good day.